Okay, we're going to do another example of a polynomial application, and if the last one made sense and you feel pretty good about it, you don't necessarily need to watch this one, but you could potentially see the problem, try it on your own, and then come back and watch the rest of the way. Either way, but here's my second example. The estimated population P in thousands of people living in a city can be modeled by the polynomial P of t equals 1.2 t to the third minus 2t squared plus 15.7t plus 3.8, where t represents the year, t equals 1 corresponds to 2001. Again, pretty similar to our last problem. Part A. Similar questions as before. Graph the interval. T is between 1 and 10. On your graphing calculator. Describe the graph. So we go to our graphing calculator, clear out my equation from the last one, 1.2 t cubed minus 2t squared plus 15.7t plus 3.8. And again, I want to be on that interval from 1 to 10, which is already in my calculator. But right now, my zoom fit is based on the last equation. So I need to go to zoom fit again, since I have a new equation in here. And as you can see, this graph looks pretty different from the last one. Now we kind of start off growing slowly at first, but then our growth picks up. Again, keep in mind the context of this problem. We're talking about the population growth in this city. So our population is growing a little bit at first, and then our population starts growing quickly. My description. I'm going to say too that the function is always increasing. Slowly at first. But then increases quickly. Part B, same as our last one. Let's find the average rate of change. Between 2001 and 2010. Average rate of change, again, we're looking for our slope eventually. And this will tell us, just kind of in general, as an average, how much was our city growing by? How many people? And kind of keep in mind too that in 2001, my t value is going to be 1. In 2010, my t value is 10. I need to get my y value. Same as before, we can get that by either plugging 1 into my whole equation, plugging 10 into my whole equation. But since I have the graph here, we might as well use our graphing calculator. Go to second calc, value, and here's my x value I can type in. If I type in 1, my y value is 18.7 for the population, which again, remember that this is in thousands. So in the year 2001, our population was 18.7 thousand, 18,700 people. And in the year 2010, our population was 1,160.8 thousand people. So it would be 1,160,000. 1,160,800 people. Average rate of change, we need to do y2 minus y1. Over x2 minus x1. And again, it might kind of help to remember what we're talking about here. Our y values is in thousands of people. Our x value is in years. Divide by 9, we get 126.9. Finally, in the context of the problem, see you, Jess. In the population, since it's positive here, on average, increases 126.9 thousand people each year. That's a pretty quick population growth.